To understand the network, we need to look at the industry as a whole, its history and the infrastructure, as well as the cutting-edge technologies that sit on top of it. Beyond the customer's premises, the network can be looked at in two parts. Firstly, the local loop. This connects the end user's premises to the local exchange and the service provider's equipment. Secondly, the service provider's network and the equipment. Originally, the whole telephone network, known as the Public Switched Telephone Network or PSTN, was owned and run by BT. However, in 2006, Ofcom, the UK communication regulator, required BT to open up its local loop exchanges. At the same time, a new organisation, Openreach, was formed to manage these local loops and treat all service providers as equals. The local loop is a copper network. Each user is connected to a pair of copper wires in the local exchange. It terminates the NTA or master socket in the customer's premises and the main distribution frame or MDF at the local exchange. Between these 2 points, the wires gradually converge with those of other users, firstly at the distribution point or DP, and then at the primary connection point PCP, sometimes known as the green cabinet. The cables from the PCP to the exchange are much larger, carrying hundreds of individual copper pairs. At the exchange, the cables break out into individual copper pairs and connect to the main distribution frame. From here, the cables are connected to the service provider's equipment. This is still a manual process where the Openreach engineer physically makes the appropriate connection. When the Openreach engineer connects the copper wires to our network at the exchange, he or she connects it to our multi-service access node or MSAN. The MSAN converts the analog voice signals to digital data and sends it down the rest of our network over the fibre optic cable. So there you have it, from the NT at the customer's premises through the local loop and onto our next generation network. However, there's one part of the network we haven't yet covered, and it's the area that most faults occur, the customer premises equipment or CPE. Testing for a CPE fault is usually straightforward. The NT at the customer's premises represents the demarcation point between ours and the customer's responsibility. Cleverly, the NT has removable faceplate. Removing the faceplate does two things. It isolates the customer's internal wiring from the rest of the network and reveals a hidden test socket that connects directly to the rest of the network. In most cases, connecting a working corded telephone directly to the test socket proves the source of the fault to be on or off CPE. However, if the fault is proven to be CPE, diagnostics is typically a simple process of elimination. If the fault is still present, there could be a number of reasons for it. The premises could be star wired, the customer has not been able to complete CPE checks, or there is an issue or outage on the network. Star wiring can be found in a few older properties where the junction box inside the property is wired to a number of phone extensions, meaning there is no clear demarcation point between the CPE and the local loop. If the customer cannot complete CPE checks, a common sense approach should be adopted. Testing for faults on the network is easy with the range of tools that we provide you with. Understanding the network, and especially the CPE side of it, is vital to delivering a better service to our customers. At TalkTalk, we want to deliver a first-class service, and together we can.